video is going to be covering some basic solid geometry. And if you're going to be a scientist or an engineer or anything along those lines, these are the kinds of things that everyone is going to assume that you know. So if you get a homework problem wrong or a test problem wrong because you're like, well, I got the area of a circle and the perimeter of a circle confused, your professor can be like, oh, wow, that sounds like somebody else's problem, not mine. So I'm going to show you what these are and also talk to you a little bit about dimensional analysis. So you can use that, even if you kind of like start to get confused in your head, you can use dimensional analysis to kind of figure that out. So let's start out with some 2D figures. So basic is just a circle, and the circle has something like radius r. Now, with all of these figures, we're going to be having something that looks like, what do you call that? Perimeter? Now, for a circle, we have a special word for perimeter, which we call circumference and area. Now, without too much trouble, you should hopefully know that the perimeter of a circle, you might think of it as like pi times d, which is fine, except that d is for diameter, and that's twice the radius. So instead of saying pi d, which might be what you learned somewhere else, we'll say 2 pi r. So we can call this 2 pi r. This is correct, you just don't see it that much in engineering. I mean, you can, it doesn't matter. Just, if you know it in the radius, you're fine. All right, and so then the other one is going to be a formula you probably already know as well, which is pi r squared. Now what happens is, of course, sometimes we'll get into a test and we'll get confused about, well, what means what? So perimeter, you always have to remember, or circumference, that's when you're going around something, right? So if you're going to buy fencing, so whenever you buy fencing, you go out and you're like, oh, I'm going to buy 89 feet of fencing. Whereas, so that's perimeter. Whereas like for area is if you're going to paint something. So if you go by paint, I mean, yeah, you buy it in gallons, but it'll say this gallon of paint will paint, 8,922 square feet of wall. And you're like, awesome, because that's about the size of my bedroom or whatever. So that's area. Now, whenever you're looking at the formulas, because what happens on tests is we all get dumb, right? You're like, I know everything. And then you walk into the test and your brain stops working. And so you get confused and you're like, okay, I need to do area. Is that pi r squared or 2 pi r? Pi r squared or 2 pi r? And then you inevitably guess the wrong one. So what you want to think about is area is whenever you're buying area, whenever you're buying something to cover area, you would buy something and say square feet or feet squared. When you're buying something that would cover perimeter like fencing, you're going to buy a certain amount of feet of fencing. Okay, now if you look at these formulas, whenever we have 2 pi r, all right, 2 has no dimensions, pi has no dimensions, but r would be measured in something maybe like feet, like the radius of this circle is 12 feet or whatever. So when you have no dimension times no dimension times no dimension, you get feet dimensions. Now, if you look at the other one, pi has no dimensions, but remember we said that r had feet. So if we're looking at feet, they're not just feet though, they're feet squared. So if I have no dimensions times feet squared, I'm getting feet squared. So you should never, ever, 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 ever again get these two confused, because if you're like, is it 2 pi r squared, 2 pi r squared? You're like, wait, the 2 pi r has to be linear, right? Linear, because it's in feet, but the feet squared has to be area because it's square feet. So I don't like buy paint. It says it covers 5 feet of wall. That doesn't make any sense. It might say 5 square feet of wall, in which case you're looking at a pi r squared thing. And you don't buy, square foot of fence. That doesn't make any sense. You buy linear feet of fence and stuff like that. So we're going to kind of review that as we go through all of these. But again, the nice thing is you should never get stuff like this confused again. But definitely everything on here should be stuff that you see forever and ever and know it kind of by heart. All right, so we've got a circle. Circle. What other shapes do we have? We have a rectangle. And usually our rectangle has a certain length. So L for length and W for width. Okay, and then we have the perimeter and we have the area. So again, if we're going around the fence, we have 2 W's and 2 L's. So 2 W's plus 2 L's. Now for the area, we have here in the center, we're going to have length times width. Okay, now I'm going to delete that actually, but we have length times width. Now I want you to think about this in case you're ever going to get confused. So basically you have a width, and then you have another width, and then you have another width, and you have another width, and you basically have L widths, if that makes sense. Or if you want to go the other direction, I could say I have a length, and 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 a length. This is thinner. So I could say I have W lengths that goes all the way across. So one way to think about it is L plus L plus L, W times, or W plus W plus W plus W, L times. Okay? And I know that you're like, I already know the area of a rectangle. I know that, but there's a reason I'm doing this, is because later on, I'm going to be like, remember how we did it with a rectangle? Blah, 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 blah. And you'd be like, oh yeah, okay. So anyway, let's look at the dimensional analysis again. So if I go 2 width times 2 length. So let's say there's no dimension for the 2, but the width might be measured in feet. And if you're like, but I'm metric, fine, meters, make it meters. I like feet better because it's funner to write. So we have no dimensions times feet plus no dimensions times feet. All right, so what that's going to give us is feet. Let me write it like this. Feet plus feet. And feet plus feet is still feet. Just like if I have apples plus apples, I still have apples. So feet plus feet is still feet. That's linear. So that's how I know it's perimeter. Now length times width, that's going to be feet times feet, which again gives us square feet. So this is an area. Woot! Got it? Okay. So looking beyond the rectangle, let's say that I've got myself a triangle. And it doesn't have to be a right triangle. It can just be like a random triangle. Whatever. Triangle. Choo. Do-do-do. Do-do-do. All right. It's not a right triangle, just a funky triangle. And with the triangle, we have sides, say, A, B, and C. And then we have a height, H. So the height of that. Now that will be perpendicular coming to the ground. So it's telling you how tall the triangle is. So again, we have perimeter. And we have area. The perimeter is straightforward. You're just going to go all the way around the outside. A plus B plus C. A plus B plus C. And now the area is going to be, basically the idea is that you have C times H, but only 1/2 of that. 1/2 of the base times the height. Now you say, how come you're putting C instead of B? Because the point is not to memorize formulas. The point is to look at the picture and know what it's saying. So although we've used base in the past or B in the past for base, in this case, the quote base of the triangle is wherever that line is going to. So if this was called, cucumber, then it would be 1/2 cucumber, you can't even tell what I'm writing. It'd be 1/2 cucumber times height. It doesn't matter what we call it. It is literally wherever this perpendicular line goes to, that's considered the base. Because basically what we've done is we've created a pretend rectangle out here, which is got the length times the width, the base times the height, the C times the H, but we're only doing half of it, right? Because this doesn't count and this side doesn't count. So that's where the 1/2 comes from. 1/2 base times height. Now, if we come over here and do the dimensional analysis, again, we've got feet plus feet plus feet. And that's going to give us just more feet. And then we have 1/2 base times height. So this is no dimension times feet, and that gives us square feet. So again, we have linear and area. Alrighty, that was super fun. All right, next onto this, we've got our parallelogram. Oh, wrong color. Parallelogram. I like that parallelogram has 2 L's in it that are also parallel. That makes me happy. Now with the parallelogram, we're also going to have a height, and then we'll have the sides A and A are going to be the same, and then B and B are going to be the same. Got it? Now for the perimeter, we're again just going to go around the sides. So we've got 2A plus 2B. And again, I think this is getting kind of obvious here that you have 2 feet, or like non-dimension times feet plus non-dimension times feet. Feet plus feet is equal to feet. And now for the area, basically what you're going to do is you're going to take this triangle that's right here, and you're going to draw it right here. And now what you basically have is a rectangle that has a side of a height and a base of an A. All right. So the area is just going to be A times H. And again, you could use base, but you can't just always say that it's B, because in this case, B is this funky, wonky side, and that's not the side that we want. So it's always looking at the picture. I think one of the biggest mistakes people do whenever they go into sciences and math and engineering is they memorize formulas and not just like actually learn what the formulas mean. And it all starts at the beginning. So A times H is feet times feet, which gives us square feet. That's parallelogram. And then the last one we'll look at in 2D is the trapezoid. Trapezoid, that's my favorite. All right. So again, we'll have some height given, and we'll make the sides A, B, C, and D. All right. So the perimeter is going to be A plus B plus C plus D. And then, of course, that's feet plus feet plus feet plus feet, which just gives you feet. I'm getting lazy, but I think you're getting the point. Now for area, this formula is a little funky. It's just kind of getting used to what they're doing. So to kind of help you understand where this area formula comes from, I'm going to redraw this trapezoid. Trapezoid. This isn't. Yes, trapezoid. B, C. All right, like that. So the sides are A, B, C, D. Now, I'm going to draw it again, except I'm going to flip it upside down. Oops, not like that. I'm going to flip it upside down like this. B, A, D. So this is still the C side. Now this is A, this is D, and this is B. So it's basically just the same thing, but flipped over. So basically what you have now is a parallelogram. Now it's a parallelogram. It is. There. Now it is a parallelogram, which means that it's just going to be 1/2 base, not 1/2 base times height. Sorry, it's base times height. Now the height is still that H, but now the base is D plus B times the height, except we actually have twice what we need. So we need to go in here and we need to divide both sides by 2. That's where I was saying again, 1/2 from I was getting excited, right? Because this is twice the area of the trapezoid that we actually need, because we haven't essentially doubled it. We've in fact doubled it. So the formula isn't base times height. It's the top plus the bottom divided by 2 times the H. So that's one way to think about it. So it's top plus bottom. That doesn't look like top plus bottom at all. Top plus bottom times height divided by 2. So if it makes sense to think about it as being 2 parallelograms that you've combined to make two trapezoids that you've combined to make a parallelogram, then that works. Some people just prefer not to think of it as that complicated, and they just like to say, okay, I'm going to take an average of the top and the bottom, and it's going to be, about this long. So you can also think about it as taking 1/2 of the top and the bottom and multiplying it by the height by just saying, it looks kind of right. But if you're wondering why it looks kind of right, it's because it is kind of right. You can see that there. Like basically what I'm doing is if I'm taking an average, I'm flipping this one to fit right here. And I'm flipping this guy to fit right here. I didn't draw that very good, but I think you get the point-ish. Yes, not that part, sorry. This part right here. There we go, that part. So you're flipping that part up to fit there, so it's kind of an average of the top and the bottom times the height again. So if you want to think about it as 2 separate trapezoids making a parallelogram, or just kind of like eyeballing it and saying that kind of makes sense, then you're good to go. But again, just to clarify, the area is 1/2 top plus bottom times height. So again, we have dimensionless times feet plus feet. Oh, I'm doing this in a different color. Heaven forbid I get my colors inconsistent. So dimensionless times feet plus feet times feet. Feet plus feet, of course, being feet. Feet times feet being feet squared. All right. So those are some basic formulas you really, really need to have down, not just in 2D, but in 3D. I'm going to put 3D in a separate video, but this will be a good start.